Today we're going to be multiplying numbers in scientific notation. To do this, we're going to use a rule that we learned in our exponent unit. When we're multiplying exponential expressions with the same base, 10 to the fourth times 10 to the second, we keep the base and we add the exponents. Same rule applies with negative exponents. 10 to the negative fourth times 10 to the negative second would be 10 to the negative 6. So when multiplying expressions with exponents, we keep the base and we add the exponents. We're going to use that, but we're going to be multiplying in scientific notation. To start, let's multiply two numbers in standard form, 15,000 times 300. And our answer is 4,500,000. We can turn that number into scientific notation. So 4,500,000 is going to be 4.5 times 10 to the 6th power. So when we're multiplying numbers in scientific notation, we can multiply 1.5 times 3 and then we can multiply the powers of 10. So 1.5 times 3 is 4.5. And if we use our product rule from up above, 10 to the fourth times 10 to the second, we would keep the base and add the exponents, and we get 4.5 times 10 to the sixth. So we get the same answer multiplying in standard form and multiplying in scientific notation. So multiplying in scientific notation can be a little quicker because we can just multiply those first factors between 1 and 10 and then add the exponents. So let's look at a couple examples at the bottom here. 2 times 10 to the fifth multiplied by 3 times 10 to the sixth. I'm going to multiply 2 times 3 and then I'm going to multiply 10 to the fifth by 10 to the sixth. So 2 times 3 is 6. 10 to the fifth times 10 to the sixth is 10 to the 11th. It's always a good idea just to make sure that our number is in scientific notation before we move on. 6 is between 1 and 10, so we have a power of 10. We're all set. 1.5 times 10 to the negative fourth times 6 times 10 to the negative third. We're going to multiply 1.5 by 6. And then we're going to multiply 10 to the negative fourth by 10 to the negative third. One 1.5 times 6 is 9. 10 to the negative fourth times 10 to the negative third is 10 to the negative seventh. Again, 9 is between 1 and 10, getting multiplied by a power of 10. That's written in scientific notation, so we're good. All right, on this next page, we have some practice problems I want you to try these 4 practice problems, and then we'll go over the answers. All right, so you've tried them, you got your answers. Let's do them. 3.4 times 10 to the 4th multiplied by 2.5 times 10 to the 3rd. We're going to multiply 3.4 by 2.5, and then 10 to the 4th times 10 to the 3rd. 3.4 times 2.5 is 8.5. 10 to the 4th times 10 to the 3rd. We add the exponents and we get 10 to the 7th. 8.5 times 10 to the 7th. 8.5 is less than 10, multiplied by the power of 10, so we're good. And number 2, 5.6 times 10 to the negative 3rd times 1.3 times 10 to the 6th. We're going to multiply 5.6 by 1.3, and then 10 to the negative 3rd times 10 to the 6th. So we get 7.28 times 10 to the 3rd power. Number 3, 3.9 times 10 to the 7th multiplied by 2.3 times 10 to the negative 4th. 3.9 times 2.3 is 8.97. 10 to the 7th times 10 to the negative 4th is 10 to the 3rd. And number 4, 2.2 times 10 to the negative 2nd multiplied by 4.1 times 10 to the negative 8th. Two point two times 4.1 is 9.02. 10 to the negative 2nd times 10 to the negative 8th would be 10 to the negative 10th. All right, so far we've multiplied numbers, and every time we've ended up with a product that is in scientific notation. But that's not always going to be the case. All right, so again, let's start with some standard form numbers. 60,000 times 4,000. All right, we got 2, 4 with 7 zeros. So that is 240 billion. And if we convert that to scientific notation, 2.4 times 10 to the 8th power. So now let's look at those same numbers written in scientific notation. 6.0 times 10 to the 4th is 60,000. 4.0 times 10 to the 3rd is 4,000. We're going to treat this the same way as we did on the previous page. We're going to multiply 6 times 4. And then we're going to multiply 10 to the 4th by 10 to the 3rd. So 6 times 4 is 24. And 10 to the 4th times 10 to the 3rd is 10 to the 7th. 24 is not between 1 and 10. So this is not in scientific notation yet. So what we talked about previously is that we can shift the decimal point over, but we have to adjust our exponent. So when we move the decimal point to the left, the exponent increases. So we move it over 1 to the left, we increase the exponent by 1. Now we have the same answer as we got when we multiplied in standard form. All right, so let's look at a couple more examples here. 5.2 times 10 to the 6th multiplied by 3.1 times 10 to the 2nd. I'm going to multiply 5.2 and 3.1. And we're going to multiply 10 to the 6th by 10 to the 2nd. Five point two times 3.1, we get 16.12. And 10 to the 6th times 10 to the 2nd is 10 to the 8th. 16.12 is not between 1 and 10, so we have to shift that decimal point over. We got to remember to adjust our exponent. So 16.12 becomes 1.612. And our exponent goes up from 8 to 9. 8.4 times 10 to the negative 4th multiplied by 7.25 times 10 to the 8th. We're going to multiply 8.4 times 7.25. And we're going to multiply 10 to the negative 4th times 10 to the 8th. Eight point four times 7.25, we get 60.9. And 10 to the negative 4th times 10 to the 8th is 10 to the 4th. 60.9 is too big, so we got to shift that decimal point over and adjust our exponent. So we get 6.09 times 10 to the 5th power. All right, so this next page is some practice. So I want you to try these and then come back and we'll discuss the answers. All right, 6.1 times 10 to the 4th multiplied by 2.6 times 10 to the 3rd. We're going to multiply 6.1 times 2.6 and then 10 to the 4th times 10 to the 3rd. All right, 6.1 times 2.6, 15.86. And 10 to the 4th times 10 to the 3rd is 10 to the 7th. 15.86 too big, so we're going to shift it. 1.586, we're going to adjust our exponent from 10 to the 7th to 10 to the 8th. 5.3 times 10 to the 4th times 3.5 times 10 to the 2nd. 5.3 times 3.5 multiplied by 10 to the 4th times 10 to the 2nd. 5.3 times 3.5 is 18.55. And 10 to the fourth times 10 to the second is 10 to the sixth. 18.55 is too big. So we're going to move the decimal point to the left, 1.855 times 10 to the seventh. Number three, 4.4 times 10 to the negative sixth multiplied by 7.5 times 10 to the negative third. Four point four times 7.5, we get 33. And 10 to the negative 6 times 10 to the negative third is 10 to the negative 9. 33, too big. So we get 3.3 if we shift the decimal point. But be careful with the negative 9, because when we go up from negative 9, it's going to turn into negative 8. And number 4, 8.6 times 10 to the negative second times 2.5 times 10 to the negative fifth. Eight point six times 2.5 is 21.5. 10 to the negative second times 10 to the negative fifth is 10 to the negative seventh. 21.25, we're going to shift to make 2.15 times 10. And again, up from negative 7 is negative 6.